Guys, so we've reached an exciting point in this chapter now where we can start solving trigonometric equations. So this is our first look at this. So we're not going to be using identities, we're not going to be using transformations, but we are going to be using our knowledge of graphs to solve these guys. So when you're solving trigonometric equations, you are looking for the value, or more usually values, of theta that make that equation true. So let's get cracking. First example then, we want to solve sine of theta is equal to 1/2 in the interval theta is greater than or equal to 0 but less than or equal to 360. So the first step to solving this is to use our calculators. So you can always get your first solution using your calculator. So, step 1. If we've got sine of theta equals 1/2, we can use our calculators. Yeah, theta is the inverse sine. The inverse sine of 1/2. So if you press shift sine, you'll get a little sign with a -1, then put in 1/2, and you will get 30 degrees. So 30 degrees is one of our solutions. There's actually two solutions to this. So to get the other one, we're going to draw the graph of sine of theta between 0 and 360 degrees. Now it only needs to be a sketch. So our graph is going to look something like that. Now what we're trying to solve is sine of theta equals 1/2. So we are trying to find the values of theta where the graph sine of theta hits the line y equals 1/2. So what we've done there, we've found our first solution, which is here, at 30 degrees. Now there's another solution over here. So how do we work out the value of that solution? Well, it's very, very important that sine graphs are symmetrical. So this whole thing is symmetrical through the centre there of that peak. So the first x-intercept here is at 180. So given that 30 degrees is 30 degrees in from 0, so the x-intercept are 0, this solution is 30 degrees backwards from 180. So this distance is 30, which means this solution here is 150. So we've done 180 minus 30. So our two solutions for this one are theta equals 30 and theta equals 150. Now you can always check your answers are right by plugging in your values of theta. So if you put in sine of 30 plus equals, you will get 1/2. Put in sine of 150 and you will get 1/2 too. Okay, jobs are good for the first one. Okay, example 2, we want to solve cos of theta is equal to -1/2 for values of theta between 0 and 360. So, first step again, use our calculators to work out the first solution. So, theta is equal to the inverse cos of -1/2, which is equal to 150. and 20. So that's our first solution. Now if we sketch the graph, so cos looks something like that. So the x-intercept here is 90, this guy is 270. So we're trying to solve where is this equal to minus 1/2. So y equals minus 1/2 is a line down there. Now our first solution is this guy here, which is 120, and we've got another solution over here. Now 120 is 30 on from 90. So this other solution over here on the right is going to be 30 back from 270. So this is going to be 240. So our two solutions are theta equals 120 and 240. Good times. Okay, so let's go for a slightly trickier one. We want to solve 2 sine of theta plus 0.6 equals 0 for values of theta between 0 and 360 to 1 decimal place. So the first thing we have to do here is get sine of theta on its own. So if we start by taking away 0.6, we would have 2 sine of theta equals minus 0.6, and then if we divide by 2, we get sine of theta is minus 0.3. Now, if we inverse sine that, something a little bit funky happens. So, we would get theta equals the inverse sine of minus 0.3. But to 1 decimal place, that gives us minus 17.5. Now that is not in the interval that we are interested in, but we can still use it. So we need to sketch the graph. So what this has done, it's given us the closest value to the y-axis. So this has actually given us, so we were trying to solve sine of theta is minus 0.3. So minus 0.3 can be a line that looks like that. So what our calculator has given us is the value of theta for this intersection here. So this has given us minus 17.5. Now that is not in the interval that we want values of theta for. So we can still use this though. So given that solution is 17.5 below 0, so to the left of that x-intercept, this one over here is going to be 17.5 to the right of 180. So this value is going to be 180 add 17.5, which is going to give us 197.5, and then our other one over here is going to be 17.5 to the left of this x-intercept, which is 360. So this guy is going to be 360 minus 17.5. Now that is going to give us 342.5. So even though our calculators gave us that -1, it still allowed us to get to the ones we're interested in. So theta to 1 decimal place is 197.5 and 342.5. Jobs are good. Okay, let's go for a tan one. So we want to solve 3 tan theta equals 5. This time our interval is slightly different. We want values of theta between -180 and +180 to 1 decimal place. So, first of all we need to get tan of theta on its own. So if we divide by 3, we're solving tan theta equals 5/3. If we then use our calculator, we get theta equals the inverse tan of 5/3, which to 1 decimal place actually just gives us 59. So 59 degrees is one of our solutions. Now let's sketch the tan graph. So tan is the one that everybody hates. So remember we've got asymptotes at 90 and -90, and the graph looks something like that, and then it does exactly the same thing. So that point there would be 180, and then back here, this point here would be -180. So 5/3 is up here somewhere. So we're looking for the points where the graph of tan of theta hits the line y equals 5/3. Now we got our first one, that's this guy, which is 59. The tan is actually really nice. Aside from it being a horrible graph, once you've got one solution, to get any others, you just add or subtract 180. So to get this guy down here, we just do 59 minus 180. Now the reason for that is tan has a period of 180 degrees. So every 180 degrees it repeats itself. Now 59 minus 180 is minus manual maths, minus 121. So our two values of theta here are theta equals 59 and minus 121. Good times. Okay, last one for this video then. So we want to solve 3 cos theta equals 2 for values of theta between 0 and 360 to 1 decimal place. So we always need, in this situation, to get the trig function on its own. So we first of all need to divide by 3, and we'll get cos theta equals 2/3. Now, if we use our calculators, we get theta is the inverse cos of 2/3, which to 1 decimal place is 48.2 degrees. So there's our first solution. Now if we draw the graph, so cos starts off at 1, goes down like that, 2/3 is something like that. So again we are finding the points where the cos graph hits the line y equals 2/3. So we have found this first chop here, which to 1 decimal place is 48.2. Now that is 48.2 degrees in from 0. So this other solution here is going to be 48.2 degrees back from 360. So 360 minus 48.2 is 311.8. So that is our second solution, 311.8. So our two values for theta here are theta equals 48.2 and 311.8. Good times. Okay guys, hope you found this one useful. Next up, we'll be looking at more tricky ones.